Applications of matrices. Using matrices to do calculations and find new information is usually why we're doing any matrix multiplication. Obviously, for very small matrices, it's usually easier just to work the answer out without matrices. But matrices are used in computing when our matrices are order of 1,000,000 by 1,000,000, and that's when they really come into being very useful. So we've got this information about 4 people buying pens, pencils and grid books. The number each of them bought is given in this matrix. And it has asked you to create a column matrix of costs and use it to find the total spent by each person. Now, you'll do this with your graphics calculators because this is a big matrix multiplication, but we need to know how matrix multiplication works. Check the order of this one. 4 rows, 3 columns, 4 by 3. So whatever I multiply it by will have to be a 3 by, and in this case it will be a 3 by 1 column matrix. So costs, C, of pens, pencils and grid books will be 1, 2 and $1.50. So that's a 3 by 1 matrix, and you can see that we'll be able to multiply row, pens, pencils, books by column, pens, pencils, books, and we'll get an output of the total spent by each person. When we multiply one matrix by another, the output that we'll get will have these first matrix headings. So when I do my answer matrix, it will be 4 by 1, telling me it will have 4 rows showing the total from each of these. So this first matrix that we put here gives me the output row headings. I'll do a different color. Output row headings. And my second matrix that I'm multiplying by gives me my column heading of my output matrix. So this will give me the names and how much they spent, which is really quite handy. So we've done our column matrix of costs. We could do this on our graphics calculator, and since I'm going to ask you later to do this matrix times some other matrices, it's worth taking the time to get it into your graphics calculator. So a reminder, second matrix, edit, change the order of the matrix. This one's a 4 by 3. I'll just move up so we can see that I'm hitting enter there. 2, 1, 1, oops. So you see it's quite quick to get your matrix in, and it's worth it to not have to do all the stuffing around. Get our next matrix in, matrix, oops, second matrix, edit, next matrix down, doesn't have to be the same letter, can be if you want. I could have chosen C. This is a 3 by 1 matrix. And quit out. So then all I need to do is matrix A in this by C. Well, I've got A by B. And that's just into the matrix menu, either move to A and hit enter, or just hit 1 for matrix A. You can put the times sign in. You don't actually need to for a times sign. Back into the matrix menu, select matrix 2 that I wanted, and it outputs a cost matrix. So matrix N times C, we had the column headings of row headings from the first matrix, and it's a 4x1 matrix with the cost heading of the second matrix, the column heading. Because it's cost, put it in as 2 decimal places, but our dollar sign does go outside our matrix. So really quite a quick way of getting that output information. Another quite interesting thing that we can do with matrix multiplication is multiplying by row or column matrices with ones only. And it looks a bit weird, but have a look at what happens. Check the order of matrix NB. Well, we'll check our orders up here. This is a 4x3 matrix. This is a 1x4 matrix. This is a 3x1 matrix. So you can see that I can multiply matrix N by matrix B. N has 3 rows, so 3 columns, B with 3 rows will multiply by it. So the order of NB will be, so I've got N times B, 4 times 3, 3x1. Yes, I can multiply them. The order will be 4x1. Calculate the matrix. So now you'll see that I've got to enter this little column matrix. Just go your next matrix down. Oops, I forgot to do edit. So this column matrix B is a 3x1 matrix. It's just ones. Hop out and do my matrix times that one. Select matrix A times, you've got to stay on top of what you called them, which I know can get a bit confusing. I get a 4x1 matrix. Sorry, I'll just move that. Now remembering that I said when I multiply 2 matrices together, this gives me the headings for my rows, so I've still got Avon, Blaze, Cade and Dell. What does this show? 4 for Avon, 1 for Blaze. It's added up automatically what the total number of things that each of them bought. Obviously, we could just do that in our heads. 4, 1, 5, 6. But for a much larger matrix, this would be a lot quicker. Now, this row matrix, A, you'll see I've said the order of A times N, not N times A. I can't do N times A, but I can do A times N. So, A by N, write in, I've got 1 times 4, 4 by 3. That says, yes, I can do this. This says my order will be 1 by 3. Now, if I'm multiplying by A first and N second, that means these will be the headings of my columns. So, get this matrix into your graphics calculator. This is a 1 by 4 matrix. just ones in everything, and my original matrix times that matrix I just entered, I've done something wrong. I did my original times A. I got a dimension mismatch. It's telling me I can't do that. That's very helpful. Wrong thing. I've got to start with the matrix I just entered, matrix D. Do that times my first matrix. So when that happens, you know that your matrix is undefined. And that remembering that I said my column headings come from the second matrix, so this is pens, pencils, books. Multiplying by that row matrix added up the total of how many of each things was bought. It totaled the columns. So these row and column matrices can be really quite useful for quickly adding up rows or columns in a large matrix.